Hey y'all, Data Guy here, and today I am here coming at you with a video on best practices for running Apache Kafka in production. Apache Kafka is, as you know, everyone knows, kind of really the de facto standard for distributed event streaming, because it's capable of handling up to trillions of events per day. But running Kafka at scale in a production grade environment requires a lot of careful tuning, a lot of careful attention to details across your hardware, configuration, monitoring, how you're running security, and how you're really architecting your entire solution for running Kafka, because it does require a lot of compute to process trillions of events per day, as you might imagine. So that's what we're really going to explore in this video. Is going to cover, probably like 9 or 10 of the top best practices, tips that you can use for your own Kafka setup to make sure that you're running Kafka as efficiently as possible. If you like these videos, please like and subscribe. It helps me out a lot. And if you want to see videos a week in advance, join my Patreon for free. So without further ado, let's get into it. So the first thing you're going to want to think about when you're designing your Kafka environment is your cluster architecture. And the number one thing you should be thinking about is planning for high availability. Typically, you're going to want to set a replication factor, typically 3, for each topic to ensure fault tolerance. And also, in parallel with that, use a distribute partition to a partition count that will balance throughput and parallelism, and avoid too many small partitions. Really be thoughtful about where you're using them for the greatest, actual partitioning, rather than just having a lot of smaller partitions. That's never really an effective strategy for scaling Kafka. Also, make sure you're using multiple brokers. So in this example, you actually have those 3 topics, three replicated versions of the example topic running on 3 different brokers. And here you also want to think about spreading them out across availability zones to tolerate node or zone failures, so you actually can keep running even if there's an outage in a particular availability zone. They can switch to another broker for processing those messages. And then also a popular thing is or old school was, you used how to use Zookeeper for managing many Kafka topics. Now, Kafka 3.x supports Kafka Raft metadata mode, which allows you to eliminate Zookeeper and use Craft for new clusters to simplify operations. So you can use that for actually tracking all these different brokers and topics without needing to plug in Zookeeper on top of it. But for legacy clusters, still probably going to want to run an odd number of Zookeeper nodes, usually 3 or 5, for safety with your quorum. So now the next thing I want to talk about is how you can optimize your broker configuration. So Kafka by default will use OS page caches, so avoid memory swapping if you can. And always think about using dedicated disks for Kafka logs, and preferably use solid state drives for high throughput workloads, so you have those really fast read-write speeds so your top Kafka topics and streams can process the data as quickly as possible, which is pretty crucial in areas where Kafka is used. And also make sure you're configuring and tweaking log retention hours and log segment bytes to make sure you're able to control disk usage, especially when you're dealing with really high capacity workloads and you're trying to optimize to fit it on a certain number of compute. Then for I/O and network, make sure you're setting the number of network threads and the number of I/O threads based on the expected load. So calibrate the number of threads based on the amount of parallel, input events you expect to be occurring at one time. And then also making sure you're enabling your socket buffer bytes and your for both sending and receiving to match the network capacity that you're actually running your Kafka network or Kafka cluster in. And try to get up to 10 gigabytes per second in production environments for those high throughput applications. And finally, for heap size, try to avoid allocating all your system memory to the JVM. Kafka will actually perform better with a 6 to 8 gigabyte heap in JVM, and then the rest is available to the OS to kind of run the overhead systems there. So the next thing you want to optimize is your Kafka topics itself. And here, as you can see within a Kafka topic, you're going to have many partitions for, the degree of parallelism you want within a topic. But more partitions is also going to increase your metadata overhead. So a good rule of thumb is, using 1 partition per each consumer thread that's going to be consuming from the topic. And also making sure, reassess your partition count before you increase your topic throughput to make sure you have enough partitions to handle your increased throughput. Similarly, also to your broker configuration, make sure you're defining topic retention thoughtfully, so that you can also implement things like compact topics using cleanup policies to make sure you're not keeping topic retention or topic data too long after it's already been sent to external consumer systems, but you also are keeping data long enough that you're not losing it for troubleshooting or logging. You want to be careful with unlimited retention because it's likely to lead to disk exhaustion at some point. Now, the next topic I want to discuss is everyone's favorite, and that is security best practices. Around your Kafka environment, you're going to want to implement a lot of security services to actually make sure that Kafka is running securely. All the different network operations are occurring over secure rails. And number one thing you want to implement, and you can see that here, is implementing TLS for encryption and setting that as your protocol so that all traffic from Kafka consumers to brokers is going to be encrypted. Also, enable SASL or Kerberos typically for authentication to make sure that you're not just able to connect to, through standard key password. Make sure you're using secure Kerberos and SASL ways of actually connecting to Kafka. And also making sure if you're still using Zookeeper or Craft, securing your access to those services with the same SASL authentication provider that you're using for the core Kafka environment as well. Additionally, you might want to think about implementing access control lists so that you can only grant access to certain services, certain IP ranges, certain users, and make sure that you're operating on privilege or least privileges access controls basis. So only define fine-grained access per user, per topic, per consumer group, per cluster action that they actually need to undertake. Don't just give someone global access and expect them not to do anything bad with it, because obviously that's a poor approach. Now, the next thing I want to talk about is optimizing the relationship between consumers and producers and the best practices there. Number one, you're going to want to make sure you're using idempotent producers and enable that flag, enable idempotence, to prevent any duplicate messages that could gum up the works and obviously cause bad data being produced from your Kafka topics. Also, try to batch records, set batch sizes for higher throughput. If you can't process every piece right as it's produced, batch records is a great way to kind of hit a middle ground there. And also use compression on your data from the producers to reduce the network load. So you're not just sending raw data, you're actually compressing it so it's as lightweight on the network as possible. Then on the consumer side of things, make sure you're always tracking your consumer group lag and identifying any consumers that have increased or decreased or increased their latency. And then make sure you're tuning the maximum pull records and session timeout time for optimal batch sizes and also group coordination. And finally, set the auto offset reset to earliest only for testing or bootstrapping. It's really not something you're meant to be using in production. Just kind of only want to have that auto offset when you're actually just testing out initial setup of the Kafka cluster. Now, the next thing I want to talk about is the process of upgrading your Kafka cluster. Always make sure you're performing your upgrades one broker at a time. Don't try to do one big mass upgrade. And also, test thoroughly in staging. Have a setup, kind of smaller replica of a Kafka environment that you can use to check compatibility for updates to any protocols, configurations, client libraries that you're using so that you don't just, push an update and immediately have things fail and wonder what the heck went wrong. And then as you're scaling, your Kafka environment horizontally, just make sure you're adding more brokers and rebalancing permissions on a regular basis using the built-in Kafka reassign partitions script, which will actually help to rebalance using some already built-in Kafka logic, so you don't need to do anything yourself. Now, the final topic I want to discuss is disaster recovery and backup. This is especially crucial for Kafka because likely, your Kafka environment is going to be supporting really critical production workloads. So making sure you have regular backups of critical metadata like top configurations, ACL lists, and then also mirroring critical topics to another Kafka cluster are crucial. That's going to allow you to have, you can see this example, you have region 1 and region 2. You can use Mirror Maker 2.0 to automatically mirror your critical topics to another Kafka cluster, so you don't need to set up the logic yourself. There's tooling to do so. but make sure you have, basically a smaller standby Kafka cluster that is ready to turn on in a different region, on a different cloud, whatever. If there is some outage to your primary Kafka cluster, and then make sure you have automated failover procedures that you can then test and test your automated recovery plans as well. Implement that in staging environments, making sure, hey, if I'm going to do some kind of chaos testing, like with a tool like Chaos Monkey or ToxyProxy to test resilience, and if there is a failure, test my ability to fail over to another cluster. All crucial for making sure you have a solid cluster or Kafka environment that is resilient to those kind of black swan events. And then just some final recommendations to leave you with, that don't really fall up in other categories. Make sure you're automating your cluster provisioning with tools like Terraform and Ansible or Kubernetes and Strimzi. Document your Kafka SLAs so you have expectations of, hey, we expect things to be this latent, what my availability and DR expectations are, and also perform regular, like quarterly audits of topic usage and try to prune any unused resources to make sure you don't start spending a lot of money on a Kafka environment that doesn't provide equal value. So that's all I have for you today. I hope you enjoyed this video. I hope you have a great rest of your day. Data Guy out.